Welcome to Paris Mountain State Park in Greenville, South Carolina. I'm Ranger Kathy Taylor. When second graders come to Paris Mountain, they are our scientists for the day, investigating the many life cycles that go on here. How do they investigate life cycles? Well, they observe nature. They step into Mountain Creek that's behind me here and find some animals that are growing up there. They do some measuring. For instance, they measure the temperature of the air and of the water while they're there. They record that, and they measure how long some animals are that are from the creek, that were found in the creek. So all of this helps us understand the life cycles better. So now we're going to work together to practice measuring the temperature of the air and of the water. If possible, use your life cycling pre-visit worksheet called Using a Thermometer. Temperature anyway? Well, we talk about temperature when we're talking about how hot or cold a day will be, or someone has a fever or not. But what is it? Well, we know it's a measurement of the amount of energy in an object. We could also say we use temperature to get a measurement of how hot or cold something is. So it measures the amount of energy in an object. We know on a thermometer, like the ones that the students use here, that there's a red liquid there. And since we know heat causes things to expand and cold causes things to contract, well, it turns out that the little red line goes up, rises as it expands with heat, and contracts or goes down, the line goes down with cold. So that's pretty cool, isn't it? Are you ready, scientists? What are we going to use to take the temperature? We're going to use a thermometer. And you might notice I'm holding it at the round top. Why wouldn't I hold it down here? Well, I want to be taking the air temperature, not my hand temperature. So let's take a look at this thermometer. See where it goes up to. By that, I'm referring to the red line that I see on there. Do you see a red line? And we also have numbers. Do you see the 10, the 20, the 30? So there's also lines in between the 10 and the 20, in between the 20 and the 30. We count all that together and see where the red line goes up to, and that's what we'll say is the temperature. Is it near the 20? Is it on the 20? Whatever you get, you can write down on your field sheet for air temperature in Celsius, because we know that scientists use Celsius all over the world. So let's do the water temperature next. We're going to be measuring the water temperature soon from the creek, so we're going to need a bucket of creek water. To measure the water temperature, I have water that I already collected from Mountain Creek, and I've poured 100 milliliters of water into a 250 milliliter beaker. And so next I'll place the thermometer in the beaker, and I'm going to set my timer for 2 minutes. Why am I doing that? Well, I want to give the thermometer time to read the temperature. It's gone from the air temperature to the water temperature. Hey, do you predict that the water will be warmer or cooler than the air temperature? It does vary, but you make your prediction. And let's think about the importance of temperature in terms of life cycles. Take dragonflies, for instance. We know that baby dragonflies grow up in Mountain Creek. We call them nymphs. And each species of dragonfly has the perfect temperature for moving around and eating. Did you know that? If it's a little bit chilly compared to that temperature, or a little bit warm, the baby dragonfly won't get around as much. And if it gets below a certain temperature, the baby dragonfly won't eat at all. It'll just wait for the temperature to get more comfortable. Do you stop eating when you get cold? No, but that is very important in terms of a dragonfly's life cycle, and in terms of many of the animals that live here in the park, especially those that are exothermic, in other words, for cold-blooded. They rely on the temperature to be right for them to move around even. So with dragonflies, we know that it makes a difference in terms of how quickly they grow up. Temperature and the amount of food available are the two main factors that determine how quickly a dragonfly grows up. What about an adult dragonfly? Is temperature still important? Well, sure. The temperature has to get to a certain number for the adult dragonflies to be able to warm up their wings enough to fly. And when it gets really hot, you may notice a dragonfly sort of tilting its head a little bit like a handstand. And why does it do that? It's called obelisking. That, by tilting itself instead of being flat out, it gets the less of the direct sunlight. So it makes a difference to it. Okay, let me check the temperature. Oh, we're getting close to 2 minutes. Count with me. We have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's see if the temperature is higher or lower than the air temperature. Let's take a look. Can you see where the red line goes up to on there? Is it above or below the 10, above or below the 20? Is it lower or higher than it was before? Well, I'm taking a look here. I can see about halfway between the 10 and the 20 would be 15, right? So is it above or below with a halfway point between the 10 and the 20? So whatever you get, I'm getting a little bit above 15. So what would you write on your sheet? Whatever you get, you can write that down for the water temperature in Celsius. And it also asks on your sheet, how is temperature important to an animal as it grows? Well, we just talked about that some, right? About the dragonflies, and you can write about that, or you might know some other interesting facts in terms of how temperature plays a role in life cycles. For instance, have you heard that in a nest of baby turtles, of turtle eggs, I should say, if the nest is above a certain temperature, like particularly warm, all the baby turtles hatch out to be females. And if the nest is a bit cooler, then all the baby turtles hatch out to be males. So that's pretty important, right? So there's so much to learn about our great outdoors, including the temperature and its role with life cycles.